All right. Is it working now? Is the big question. It does say live, unstable, it says. Oh, session says 27 seconds. Seems like it's working. Working now! Little Annie is here. My biggest fan. Always. Coming to you mirrored, well, unmirrored today because you have to be able to read my t-shirt. Anyway, how are we all doing today? Hey, little Annie. How is my sound? I changed some sound settings. Can you tell me how my sound is? No response. Okay, let's see what we are doing today. Let me do day 17. Day 17. Oh, little Annie just subscribed. Well, I hope she gets her money's worth. I think she does. Input. Day example, and then we open up day 17. Here we do close others. We close others here. We drag this example. We drag the input. Close example. Okay. Module main where import util language GHE 2021. What is going on? Sounds good. Sounds good. Good. Nice. Let me check. Okay, so we're going ham today. We were streaming for 3 hours yesterday. It was a hard problem, but that's how it is. We ended up getting a hint from Reddit. I hope we don't have to do that today, but you never know. Okay. This is so state-based, right? We're always calculating some sand state updates. Let me see what the input is. Okay, this is the input. Okay, let's see here. Oh my god, I can't even copy it. Like now, let's read the story. You had the last book at the alternative accident K, free on the elements. Ground is rumbling continuously now, but the strange valve project is on time. It's definitely getting warmer in here though. You sounds imagining open a tall, narrow chamber. Large, oddly shaped rocks are falling into the chamber from above, presumably due to all the rumbling. If you can't work out where the rocks will fall next, you might be crushed. The 5 types of rocks have the following peculiar shape, where hashtag is rock and dot is the empty space. Okay, it's almost Tetris. Let's say paste this here. Let me see. Okay. The rocks fall in the order shown above. First the ling, then the dash, and then the plus, and then this one, and then the lizard in the same order repeats. J falls first, 6th, 11th, 16th. Okay. The rocks don't spin, but they do get pushed around by jets of hot gas coming out of the walls themselves. Quicksand reveals the effect of hot gas as they fall. In jet patterns, left means a push to the left, while right means a push to the right. In the pattern means that the jets will push a fall on the right, right, then left, right, left, then so on. Okay. If the end of this is reached, it repeats. The tall vertical chamber is exactly 7 units wide. Each rock appears that it has the left edge. It's 2 units away from the left wall, and its bottom edge is 3 units above the highest rock in the room or the floor. Where is the floor? Okay, right. Rock falls 1 unit. Okay. Rock falls 1 unit, causing it to come to rest. Oh my god. Okay, this is seems to be okay. Let's just simulate this. So where is the floor? Uh, 3 units above the highest rock in the room or the floor if there isn't one. Okay. Let's see. So, I mean, the one way to do it would be to... So each rock will fall 3 units. Right? Until possibly hitting something below. Okay. So we just have to check whether after 3 units of the current shape, whether it will intersect with one of the... So we will dig up our range code again. Yeah, we've been trying to do this, but it didn't work. Dun, 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 dun. And some water. You might have the case where, you know, like there's a T and it stands like this, and there's another T on top of the T, and then there's like one that goes chick, right? Like falls in like that, and then it will be like stuck, but it will not. We will not catch it, right? Because, you know, the highest point and the lowest point, it will not work out. I think we just have to model it directly. Okay, let's start from scratch. Okay, CP day 17 dot adjust day 17 initial dot adjust. Okay, now we're just gonna delete all these. And we might, you know, copy it back later, but we don't. Now we're just gonna. We're just doing too much premature optimization. Okay, we're gonna keep the sequences for these. Okay, and this is just gonna be return I true and return I false. And then we're just gonna have here bool. Okay, and then we're going to print imps. And we're gonna say, okay, the true. We keep copying it. Oh no, that means we deleted everything here also. Okay, let's go back then. Like that. Now let's okay. And then we're just gonna keep the whole block. It's just gonna be a set of points. No optimization at all. Okay. Ding. Yeah, we can actually. Okay. Yeah. Ding 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 ding. So type block is gonna be an int map of ints. Okay. And we're gonna have the y coordinate, and then we're gonna have the x coordinates. Okay, now we have to rewrite all the blocks. Let's reopen day 0, day 17 initial. Okay. Okay, so blocks is a list of set of ints. No, so list of block. Okay. Import data dot okay, and then import data dot int map. Okay, we have int maps already. Blocks. Okay. We're gonna just look at So the annoying thing about these int maps is that you cannot. Okay, we can change the keys. Okay. I am dot. We had this all the way in the beginning. Map I am dot from list. Okay. So the first one is just 0,0. So zip. And then it's the. So we're gonna have it like the so it's the x coordinate and the y coordinate. Then it's not actually an int map of int, it's an int map of set of int. Okay, then this is gonna be the y coordinate 0, and then set out from list. Can I have like an int set? Yeah, I could probably have an int set. Import data dot int set as int set import qualified int set as is data dot int set int maps int set. Okay, and this is is dot from list. Is from list, and then this is just going to be 0, and it's going to be just 0, 2, 3. we're not gonna be doing any clever modeling here. Okay, this is the first block. Okay, second block. Ding ding ding. Ding 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 ding. Ding 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 ding. Second block. Third block. And then we have the fourth block. We have the fourth block. Wait. 1, 2. Oh, we have 5 blocks actually. Yeah. Okay, now this one goes we're gonna do it downwards, okay? 0, comma, is dot singleton 1, and then 1 is is dot from list 0 to 2. And then we have, oh no, yes, sorry, these are not like this actually. Yes, okay, and then we have another singleton. One also. Okay. Actually, I'm just gonna copy this one for the next one. This is 0. 0 is singleton 2. 1 is singleton 2. Well, and 2 is from list 0 to 2. Okay, this one is SIP is 0 to 3 of repeat is that singleton 0. Oh no, well, it's not a list actually. Okay, and this one is zip 0 1 repeat is from list 0 1. Look, this is a list, this is a list, this is a list, this is a list, and this is a list. Sorry, we'll come here. Okay, let's print out the logs. Okay. Now we're gonna do the action. Okay, so we do the action. So shift right takes an int map int set to, so take a block to a block. Okay, and so shift right is equal to im dot map sr, where sr takes is equal is dot map monotonic. This takes this is, and it just, this one bumps to this is just +1. Shift right, shift left. Shift left is equal to dot map sl, where sl is equal to is dot map monotonic x minus 1. Okay, that's how you shift right and you shift left. So then we write the we just write the write fall block to block. Fall is equal to im dot lms, no, assocs. So we do im dot from ask list dot im dot map x comma y to x plus 1 comma y, no, x minus 1 comma y. Ding 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 ding. It doesn't like this because it's not im dot map. This is how a block falls, and then we can shift left and we shift right. Okay, ding 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 ding. Okay, and now it'll do collision. Takes okay, let's use just type floor is also an int map int set. Collision floor block bool. Collision fl block is equal to then I just check if any of the sets collide. Union with. Okay, so the union, so then we take then we take the im dot union with okay, okay, we don't actually need here this FLPL. So now we're taking the union of the two, all the points. And we'll do the union is gonna be is dot intersection And we're going to do is dot empty. Let's do better here. So im dot intersection. So here we have the im dot intersection, and then we take the intersection. Ooh. Then we have an intersection. Oh yeah, an intersection width. Okay, so im intersection, im dot intersection width. S. Okay, and then we do, so then we have the floor blocks and the, so this is, here we do is dot intersection. Yeah, and then we do is dot empty. And it doesn't like this because we, okay. Could match action block int map inset int map okay, yes. So now we have intersection, and we want to check that all of these are, well, empty. Inset Haskell. Oh, Joachim Breitner was working on this. He is a legend. Okay, well. So we check whether the intersection is empty. Okay, so that's what we're doing. Is dot disjoint. Now I want to check. So I have the intersection and then I have the disjoint. And then I'm just going to do the elements. I'm going to do a and im dot lm. Floor int map inset int map boom. Oh, okay, so this is the FL and the BL. Okay, where is equals FLBL. It's gonna be is int map. Okay, and I'm gonna say, so I want to check that I want to see that they're all disjoint. So I'm just going to do and is. Okay, so that's how we do a collision. Okay, and this is like super over the top, right? But I was very tired of what we're doing before. Okay, but I'm gonna say here ball, and I'm gonna say also bump. I'm gonna say lift up int block lift up equals I equals I am dot from ask list dot dot map map x comma y x plus y dot I am dot asox comma y y mod. Okay, now and then fall is actually just fall is equal to y mod minus 1. Now, okay, let's simulate. Okay, so initial floor is floor. Initial floor is equal to I am dot from list. Now I am dot singleton 0 and it's gonna be is dot from task list from distinct task list 0 to 6 is the initial floor from this. So this one doesn't matter. Int map from, can I route it from distinct? Yes, very good. Okay, I think because I'm doing all map monotonic distinct task list, I mean these are all just views. Boom boom. Okay. Boom 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 boom. Dum, 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 dum. Okay. How is everyone doing, by the way? This has been a long stream. I mean, but we restarted, right? So. And I've been taking breaks, all like that. It's okay. Okay, now we have the initial floor, and let's now write the simulate function. So what we had this nice construction here where we had like stop and collides and simulate. Okay, simulate num blocks floor, and then we have the current block, and then we have the input. Simulate int floor block seek input floor. Bring, 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 bring. Let me actually do a render floor. Takes in a floor and returns a string. Okay, a render floor. Okay, we say here where max y is equal to fl. Okay, max y is equal to im dot find max find key max view with key find max y comma, I don't care about the value there, im dot find max fl. Now check x comma y is gonna be equal to, first of all, if a im dot bang a y fl a case just x is equal to comma is equal to x is, we're gonna go x is dot member xs equals otherwise equals false. So I am going to do here for m for a, so this is going to be the y coordinates, 0 to max y y for a and the axis go to 0 to x, so 0 to 6. Let's do import data dot foldable. Oh, I have it as fl. Let's see here, fl dot for a fl dot for a, and then we do x, and I do if check x comma y, then hashtag else dot. Now what does for actually do? So this is gonna be the, this is gonna be a list. Okay, let L equal in L plus plus. Okay, let's see, 4 traversable, sorry about that. Import data dot qualified data dot traversable str. No, let's just import data dot qualified, no, data dot traversable traverse. Then this will actually be a flip traverse, and then flip traverse 0 to 6 $x, and then I do all this stuff. Let L equals in L plus when it doesn't like this. Let's just do IO. Okay, I don't care. IO string IO 4m max y dollar y to 4m $6 x we do here a put string if check so do okay x put string, and then this is just do, and then here we do Mr. Allen, and we do import control.monad 4m. Okay, now let me render the floor here. Render floor initial floor. Oh yeah, render floor. And we're actually gonna do it to pro max y plus plus 4. But I'm going from the reverse. I want to do this in inverse. Okay, now if check xy, then x is member x's, and the initial floor. Oh yeah, because this is the floor. Okay, so we're actually gonna do here 1, and then we're gonna say 2. Okay, and then we're gonna do this, and then we're gonna say put ln replicate replicate 7. This is the floor. Okay, and then ding ding. Now simulate. We get the int and the current floor and the block and the seek input. Return a floor. Okay, simulate. Block floor. Don't care. Case block equals 4. Block equals 1 is equal to 4. Okay, simulate. Block floor and the current block, and we have this input imps. Okay, so collides, we're gonna say what happens first? First rock begins falling. Okay, the jet of gas pushes the rock, right? So we're gonna do jet block to block. Jet, okay, input. Now jet I true, so this is the right, is equal to shift right. Jet I false equals shift left. So we're gonna do here. Okay, so first of all, BL prime is equal to jet imp. So first we shift it to the left or the right based on the input. Okay, and then we check. Okay, we always shift it to the left or right. Okay, equal. Okay, so where BL prime first BL prime is BL shifted is jet int of block. Now, if it collides, collision BL shifted floor collision. What was the condition here? Floor block. Okay, collision BL shifted floor. So BL prime is if collision floor BL shifted, then so if it collides, if we shift it, we don't do it, right? Else BL shifted. Okay. So we do this in all cases where BL shifted jet input. Yeah, okay. So this is how the wind affected. Prime is equal to this. If collision BL floor. Okay. Now we do fall. So fallen down 1 is going to be fall BL prime. Okay, now we're going to check a collision floor BL prime. So here if going down 1 step after shifting, then we do it's the new one. It's okay. Imps prime is equal to imps then it says simulate num block plus 1. Oh, this is going to be supposed to be okay, let's just say floor here. Floor simulate num block 1. We're gonna do floor prime and then a new block imps prime. Okay, otherwise okay, let's see, do like this. So down 1 is also always gonna happen. I mean, it's always gonna be checked. Collision floor BL down 1. Okay, otherwise it's equal to simulate num block floor down 1 imps prime. Okay, so but if it was a collision, we add it to the floor, right? So now it becomes part of the floor. So floor prime is equal to IM dot union with IS dot union floor prime floor BL prime and new block a Okay, so let's write the new block function. New block takes in the current number of the blocks, and it takes in the current maximum y, and it returns a block. So new block, no blocks, and max y is equal to so the block is going to be BL equals a blocks bang bang a num blocks mod length blocks, and I have to say we're gonna mod the we're gonna shift it twice to the right, so we're gonna do okay, we'll just do like this, blocks, and then we shift it twice to the right, shift right, color shift right, twice to the right, and then we do mod y, mod, so y mod, and we do plus max I plus 4, right? So we're always going to start we're going to start so 0, the 1, 2, 2, 3, 4. This is new block function. Okay, new block is equal to new block num block plus 1. And how do we get the maximum y? We do im dot so first of im dot find max floor prime. That's gonna be the maximum y. Something about that. Okay, so then we're gonna simulate render floor. Now we're gonna do simulate R. So simulate we do the initial, so number block 0 initial floor, and the new block 0 and the find max is 0, new block 0 0, and a right, and then the imp render floor are let fl equals fl Let me print this floor. Sorry, print fl. Okay, why did it do that? So 0, 0, 1, 2, 3, 4, 5, 6. Oh yeah, okay. Now let me see. It seems to be a collision. Bing, 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 doo doo bing, bing, bing. Maybe my collision function is incorrect. This is going to be intersection with. Now let me show you here. Ratio id. Ding, 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 ding. Okay, so it seems like it's shifted to the root. So it was 4, 3, 3, 4, 5, 6. Okay, and then it seems to have shifted to the left, but it should be shifting to the right, right? Shift right. What is that? Shift left. This left, yeah. This is Y true. Okay, and then yeah, okay. True, right, shift right. Okay, we are shifting right and shifting left. Trace show, okay. Trace show it. Let's see GCI any of the empty list is a end of the empty list. True. Right. So I want this to be I think this should be then not disjoint. Maybe I had to do fmap not FLBL. Okay. And then there should be orb. Okay. Collision and so if any of these are true, if any of these are let's just do it like that. Okay. FB. Okay, and then we do not disjoint FB. Okay, and then we say or. So if any of them are not disjoint, I think that should work. So if any of them, so because or of empty list is false. Okay. Yes. Okay. Now let's see what we get. Yeah. But it shifts to the right too much. Ding, ding. Right, okay, so blocks, initial floor, collision. So if collision floor BL shifted, or ding, 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 ding. BL shifted, so let's write the out of bounds function takes a block and returns the bool. Out of bounds is equal to any ding, 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 ding. We do actually im.lms of the block. Okay, so we get all that. So we get is.unions is.unions, and then we have a BL where all is.unions BL, and then min is equals is dot find min is max is equals is dot find max is min is less than 0 and max is less than equal to start larger than equal to 7. Oh, what do you? If collision floor BL shifted, or okay, trace show ID. Okay, so it does check the 3, 4, 5, 6, 4, 5, 6, 7, and 5, 6, 7, 8. From list, what? Find max is. What is? Three, 4, 5, 4. Ah, it's not checking the maximum. I didn't do this. Okay. Let's actually check the out of bounds first, because that's probably more common. Okay, so this was block 1. That seems to work. Now let's go for simulate for so we start at 0 always. Ding ding ding. Let's check what it does for number 2. Yes, we end up there, right? Yeah, okay. Now for 3. This one looks incorrect. Maybe it's probably because, because I did 0, 1, 2. So I'll probably have this like 0, 0, 1, 2. And now let's see if we can actually solve our problem to do this all from start. Yes. Okay, this is the right picture. Bing, 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 bing. Let's write here a max block. No block equals max block. Max block. Max block. Okay, and now task 1 takes a list of inputs, and it takes and it returns a hint. Task 1 is equal to simulate 2020 through 2022 is 0 initial floor new block 00 and it's gonna say im.find max, and we're gonna say first. Ding 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 ding. Ding 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 ding. Ah. Now simulate, it's complaining that seek input, right? Print task 1. Print imps 3068. Yes. Then I'm gonna say read input day 17 dot example print. Okay, but that was super quick, right? And I feel like it's more limited not by the jets but by the actual update. Input non-exhaustive patterns and functions simulate. Okay. Non-exhaustive patterns in simulate MBNB FBLI equals error dollar show a MBNB because I don't actually have anything in input. vsmart vsmart, then it doesn't know what to do. What is this? Yeah, okay. 3166, maybe not that many more blocks, right? All right, we got part 1 finally. This is a big number. Okay. Now it might be probably really slow. Let's see. task 1. So let's task 2, task 2. So I think what we should do here is we should prune this data structure of ours. So kind of when we've hit in a big length, we should prune it. Okay. Let's just run it. I don't care. It's gonna be a long time. Yeah, I can't really do the H-top here. Let me do the H-top on the other one. Stop. Ding, 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 ding. What could happen here is that it just consumes all our memory. That would be bad. But I feel like these, intersection unions with, n plus m. I feel like this should be not m plus n. It should be like the minimum. Ding 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 ding. 3 straight. Okay, at least, we know that this will work, right? But it will take a long, long time. Unless we can somehow prune it. We're also running it for the example as well, just to see it, but it's going to take a super long time for the example. And yeah, see, now we're starting to run out of memory. Let's kill it, and I want to see what block number we're on. It will also be... Right, so it keeps adding, like it will also be... Okay, I'm just gonna be super risky. Right, so it's going to be like block mod. We don't have the we don't get the because in the for map there's a restrict key set, right? Okay, so what we're gonna do is we're gonna say FL prime. So we're gonna say im.toAskList of FL prime. We're gonna say take we're gonna take 1,000 of these. We're gonna map X, and then we're gonna just map to this. No, this is gonna be Y. Y minus 1,000. And then we're gonna take 1,000 of this, and then we're gonna say im dot from a distinct ask list if 0 equals to ask list. Couldn't much type int with ISK inside. Okay, FL prime. Okay, im to ask list. No, let's not map the block. Okay. Now it's, oh no, yeah. Bling, 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 bling. And it's not gonna be that much better. Okay, let me cancel this. Let's just do it the old good old way. Okay, I'm gonna just keep this running for a few minutes. I'm gonna pop off. I'll be right back. I'll let you watch the graphics. Okay, but what we probably have to do here is we have to identify a cycle, right? Ding 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 ding. Let me check that actually. Let me see. Let me write a function that says new floor takes a floor and returns maybe int. Okay, new floor is equal to im.assocs. Okay, and im.assocs. This is going to be an inset, so this is is dot from list 0 to 6. Where a floor is equal to is dot from list 0 to 6. Okay, let's see here now. Let me see. List of inset. So it's gonna be filter equals floor dot snd a map fst. Let's check. Okay, where fl prime equals, so if new floor, if not null, then new floor fl prime. If null, new floor fl prime, then fl prime. If null, else error show a new floor fl prime. So I'll show the new floor and I'll also show the num block. Ding 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 ding. Drop one. I want to drop the first floor. So level 58 becomes a new floor. And then I can just offset that, right? Okay, so let's have a new number here. Offset. Okay, so let me check here. So we have here fl prime maybe int drop one list to maybe import data dot maybe list to maybe. Okay, so we have the FL prime. Okay, and then offset prime. Okay, then we just said NFS equals a new floor FL prime. So floor prime is gonna be a okay, offset is equal to case NFS of just I of offset prime case NFS offset plus I offset. Okay, and now I'm gonna call this with the max block num block offset prime. And this is also gonna be offset prime. And this is actually gonna be offset plus a first of find im dot find max floor offset prime. So and then the floor so NFS, so if there's a case NFS of just I. Okay, then I'm going to say, so the floor is going to be a take a I plus 1. I'll take from the im dot from ask list of fl prime, and I'm going to map over it. Okay, I'm gonna say map a key comma v key minus I comma v. Okay, and I'm gonna say im dot from ask list or distinct ask list. Just fl prime. Okay, and what is the problem here? Simulate have different amount of arguments. Max block, non-block, offset floor. Okay, yes. Offset. Yeah, this one was just one there. One was somewhere. Okay, alright. And then int. Now, let me just rewrite this as simulate prime actually. Simulate prime, offset prime, BL shifted, blah 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 blah. Okay, and simulate takes in a max block and imps. Initial imp equals simulate. So non-block is 0, offset is 0, floor is initial floor, and a block is gonna be a new block 0 0, and it's gonna be initial imp simulate prime. Simulate prime doesn't really work because okay, where We're gonna indent all this down. All this stuff twice. Oh. Okay. Where? Okay, so simulate prime like this. Okay, simulate prime. And then we have this other where here. Okay, and now we're not gonna have the max block here. That's just already there. Now we don't need to pass it, it doesn't actually change. Okay, and I need to make sure these are all correct. Okay, and then down one is also there, and new block is also there, and imps prime is also there. Ding, 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 ding. Okay, take advantage of one. Okay. Okay, so this is max block, initial offset, okay, floor, the initial floor block, and initial input. Simulate prime takes an int and an int and a floor and a block and a seek input and returns an int. Could have actually I applied too many arguments. Okay, non-block offset initial floor. Ding 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 ding. Ah, this is gonna be two ASCIIs, sorry. Ding 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 ding. I don't get what's wrong here. So there's one argument. Okay. There's one argument, non-block, and then there's the offset, and then there's the initial floor, and then there's a new block, and then there's the initial input. Oh right, and then this one is actually just ding ding ding, like this. Okay, and then this one is actually just simulate 2022, and this is just simulate billion, and right. But good that it actually exists in the example. So let me wait till we're running task 2. Empty map has no maximal element. Huh. Oh. Let me see here. Trace show ID. Okay, now it's super slow. For the input for task 1. Why is that? Okay, new floor. Oh no. And it all goes up. Okay. Okay, so the new floor becomes we find a new floor. And then it all gets mixed up. Let's see. Trace show. Okay, offset. I a new block. It never gets evaluated. That's a loop. What is this? Uh, mm, mm, mm. Ah, okay. Yes. Can I do two? Dun, dun, dee, dun. Okay, dun, ding, dee, dun, ding. Okay, seems to run too high. Okay, let's see actually. Let's print task 1. Actually, let's print a simulate 59. It's gonna be first simulate 2022. Paste. And I want to see here offset plus a where total equals offset plus I dot find max a floor. Okay. I am dot so first of this. First of this. And this is gonna be total comma floor. So when does it happen? Let's see, after 5 blocks? After 20 blocks. After 50 blocks. No, after 35 blocks. Okay, after 35 blocks. 3, 1, 2, 3, 4, 5, 6. There's 7 blocks. Okay, so the first one is the floor. Okay, let's do here I comma fl simulate I need to do, what did I do? Simulate 36, okay. Simulate 36 over printfl. Render floor fl. Okay, so it's like this. And then the next brick falls and probably blocks here. Okay, and now let's just bail on this. Let's see. This is just FL prime. When we simulate 36. I know, I just want to see what happens. Yeah, so there's a new floor. Okay. Okay, and this one was, so if we printed it. Now let's print this. Print. Okay. So 0 and then 58 from Liz. Okay, then I'm gonna say, okay, so what I'm gonna do here is the new floor is actually, we're gonna drop. Okay, so we're gonna say to ask list. Ask list. Okay, we're gonna drop. We're gonna drop I minus 1. Drop I minus 1. And then we're gonna, yes, this is the way. Okay. Okay, so drop I, and then we have the new floor, and the coordinates are correct, and the offset is 58. So let's simulate 2022 here. Print I. But it returns a number that's too big. Right? What was our answer for number 1? 3166. Okay, so there's something wrong with our answer still. Let me print out the offsets here. Okay, I don't want to. No, okay, yeah, I don't want to print out the example. Ding, 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 ding. Okay, then it just grows and grows and grows and grows. Okay, so there was a floor from distinct. Ah, okay. Not reverse this. Ba-dum, bing, 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 bing. Just with it, and then. What does this other trace show here? Why? Why am I getting like multiples? 58. So this is like 106. So just for a second. Then 153. Trace show offs offset I. Let me see here. GTI 58 plus 47 plus 181 plus 1 plus 16 plus 109 plus 76 plus 72 plus 100 plus 136. I don't understand why it's being added so many times. Let me see. What's anything happening? No, nothing happening. Trade so case NFS of new floor FL prime. Let f prime equals in a offset plus I comma f prime. Ding 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 ding. I only want to do this if there's an offset. Okay, 3166, and that was the solution to the previous puzzle. Okay, good. The thing was that even if I wasn't updating the floor, I was updating the offset. Okay, good. Now it's not burning every time. Okay, now... Ding 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 ding. I run this for 1,000,000 times. How long does that take? Seconds. Okay, let me see. This integer, this offset should probably be an integer. Integer, first offset plus from integral. Integer. From integral. Okay, integer and integer. So to do 1,000,000 takes... Oh my god, and then we are doing 1,000,000. Let me print out these offsets. Probably a way to short circuit it, right? Like you will reach a loop at some point. Ding ding ding, bidi 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 trace show ID. No, trace show. But of course it won't be the offset that's here, it will be the I. Yes, see, there's a loop. Beep, beep, beep. So we just figure out the loop, and then we can short circuit it. Boom, 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 beep. Okay. Now how do we check that? So what is the loop condition? So is loop takes in the num block. So the block mod, right? The offset keeps changing. It takes in and the current new floor, right? And it takes in the imp, like the current state of the imp. And it is seen case block mod comma floor comma int set dot member scene. Import qualified data dot set as set import data dot set. Okay, so is loop seen block mod for input. Okay, and we will add here in set.empty. Okay, and now we'll do here a we'll do simulate. But then I need to like run it from the I need to run it from like the, so I need to find where it loops, and then I might find like the modulus of the loop, and then I need to do it. Okay, so and then we'll say here compressed, and I'll add that here. True, false. Okay, okay, otherwise, okay, so this is when we, well, okay, and then I'm gonna say if compressed and is loop, and we're gonna have to add scene here, and we're gonna have to add scene here. No, we don't need it here. And this is gonna be set, gonna be the int, it's gonna be well, int, it's gonna be floor, and it's gonna be seek imp. And it's gonna take a long time to actually check if the seek imp is not. It would be nice if we had like a integer like current offset into the thing. Yeah, we don't have that. Okay, scene, if compressed and is loop scene block mod. I can actually write block here. Is scene and ding. So if I've seen is loop, I can just do it directly. A block, a floor, imp set dot member, a scene. Then error, a loop found, and scene. Okay, loop found plus show and num block. Else simulate, and we do a set dot insert scene. And we insert into this set, we insert the new block, we insert the floor, and we insert the imps prime. If compressed and new block floor imps prime. Seek input. So I only do this when I actually no instance for ORD input. Okay, and I'll just derive ORD. Deriving EQ ORD. So there's a loop after 2,919 blocks. Okay, okay, then we'll do loop found 219. Okay, let's write some more stuff here. Plus show. Okay, and we'll do some mods show plus show. So I'm gonna do a now I'm gonna do. Is this for the? No, this is from 1 million only. I'm gonna do a max block mod num block. This is how many times we would repeat it. No, actually, it's gonna be. We're gonna divide. So 342 times. But this is not for the billion, okay? So let's just see what it gives for a million, and then let's test it, right? We're not gonna trace show anymore. That took 10 seconds, right? So 1577186. Okay. So we'll write that here. Should give 15. Oh no. Should give. Okay. And so instead of, so now we're not gonna error. Okay, but we just compressed. Okay. So then we loop found block offset. Okay, so max block div num block. Okay, so mods. So this is gonna be a mod num block plus plus divs plus plus show max block div and num block. Okay, mods divs. Okay. So what I want to do now is I want to so instead of, let's not do an error. So what we're gonna do is we're gonna say a simulate prime. So we're just gonna jump to the end of the loop, right? We're gonna say num block times a. Okay, let's say let divs equals a max block div num block and a ding ding ding. In. Okay, now we're gonna say here simulate prime scene. So that's not gonna change, but num block times divs num block times divs. Okay, and then offset prime times divs as well. Floor prime, new block, imps prime from integral. Okay, it's it's a little off. In fact, I think it's let's print all these things. In. Okay, so we're gonna show, so let's see, show num block times divs. Okay, so I want to see what this is. So this should be like 1,000,000. This is 1,000,000 minus 1,702, right? Yes. Now I'm gonna see a show times divs from integral, and I think I'm gonna just see the offset first, and then I'm gonna see the this is the current offset. Okay, offset prime. Okay, what if I do a loop found? No, this one should be loop floor prime. Sorry about that. Okay. Set for new block floor prime imps prime set member scene. Yeah, and I should add floor prime here. Yes, okay, and then it does not it's not returning the right one. 1577186 1577186. Ding ding ding. But almost, right? It's almost there. Maybe I have to write. Okay, yes, so we started from the scratch again. Ding, 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 ding. Is it like this? No. No, I'm having crazy deja vu here. For some reason. Ding, ding, ding. So I want to reset it so it won't shut off. Ding, 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 ding. Ah, and I need to do +1 here, right? I didn't need to, but it's still not the right one. We're pushing 5 hours now. Let me see, is my camera still working? Yeah, still going strong. Amazing. Ding, 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 ding. And then it's hitting the... It's hitting the max. And then it's... maybe the offset calculator is wrong. Okay, well... Okay, let me take a quick break. I'll be right back. But we're almost there. Let's see. So I think it's okay. Let's actually not... okay, times divs +1. What's happening is that it's not... just like it's not a... Ding, ding, ding. Let me see. Okay, in error. Root found. Okay, so the so let's show here show offset prime num blocks. And we're gonna show the number of the block, and we're gonna show divs. Okay, so every 2281 blocks, we loop. Okay, so on every 2281 blocks, the offset gets increased by... what if we just do... Cont, let's see, cont equals... It's like the continue command. Now we've seen ns ns. Okay, and let's see here, cont with this new scene here. So here we'll just do trace show. Offset prime and block dollar cont set dot insert set dot singleton and you want to see what this outputs. Three, 5, 7, 2 times 2. 6340 9108 minus 2768 1186 11876 minus 11876 minus 9108. So it might do something in the beginning and then start looping. Okay, so it does something in the beginning and then it starts looping. So we have to identify the length of the loop. Deep, 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 beep, 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 beep. Okay, so the first time we see it, okay, then we'll do it like this. Do 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 do. Okay, so we'll ding 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 ding. Okay, so let's do like this. Ding ding ding. Because the loop might not be like from the initial condition, right? It will be from some looping condition. Okay, so I want to see now. Okay, so it starts off. Right, so we've seen it before. So I mean, we might do the compression a couple of times, but then it starts looping. Okay, if compressed and then and seen. Okay, then we'll have the, we'll have the cur offset equals let's just return the offset here. Offset. Okay, the current offset is a so the current offset is offset prime. Now I'm gonna run this simulate scene non-block offset floor down 1 imps prime. Okay, so the length of the loop let's put here another bool BOL business break on loop BOL. Okay, so if compressed and new block, then if BOL, so then this is flag is true, and then so now we're running it in like the if BOL, then we're gonna return there's gonna be either and then something and there or something else, and then it's gonna be from right. Okay, either. So if we're gonna break on the loop, we're gonna return the we're gonna return the block number, right? So bool set, we're gonna return the block number. We're gonna turn the offset it does in every loop. Okay, so it's like this. So if BOL, then we're gonna just return new block and offset. And we're gonna do left. Else, so this is just the right, and then this is from import data.either or data.either from right. Why does it want to? Couldn't match type a no, it is from right. But we want to not break on loop. No, and cannot match integer floor. It's either integer floor or from right. The bool set int integer initial floor block initial input. This is supposed to be not new block but num block. Ding 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 ding. Something not matching here. Case of right A 2, and then the type of this A is going to be A error. Oh no. Okay, so if break on loop, then we return this. Else, okay, else we do a let a loop res equals a simulate prime set a true break on loop set dot empty. And we're gonna start it off again with this new, with this same thing. In there, ding 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 ding. Is in EIS scene equals set dot singleton, and then this whole thing. Okay, loop res is simulate true IS scene, and I want to start it off at one block 0 because I don't want to stop it there. I want to stop it at offset is 0. Floor prime new block int prime, and this is gonna be a in error show loop res. Else if it is not compressed, cont, and where cont is 0. Let me see. We'll run it, run it to the loop, and this is the loop. So this is the loop. Like the length of the loop. So until we see the same thing again. Okay. So I want to do let me see. So loop res. So let's see here. until loop equals so this is a left LBS LOS num this is gonna be until loop. This is gonna be a num block minus LBS. Let's show here LBS. So how many do we get until we until loop num block LBS. Sorry, until loop. Okay, so okay, so so I have the until loop, right? So I have the num block, so I want to do here this is the loop size. Okay, now we're gonna do max block divs equals max block div loop size divs equals loop size. So let's write divs here until loop equals num block minus minus loop size. Show until loop divs. Okay, so it's 530 and then 571 times the loop. Okay, so we will now do here we will do right, it's gonna be final res. So we're gonna run it again, but we're not gonna run it until full loop. So final res a final floor equals, and now we're gonna simulate prime a set dot empty simulate, and now we're gonna say false. We're not gonna break on loop, but actually yeah, this will be fine. This can be whatever. True set empty and then we're gonna say 0 0 floor prime new block imps prime, but here we're gonna have a divs times. Okay, so we're gonna have the until loop plus divs times loop size. Okay, and let's print here final res. Okay, does it hit the loop again? Did you not hit the loop again? Okay, divs times loop size. Ah. Ding 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 ding. Let's see. Okay, maybe this has to be num block. Oh my god, why does it hit the loop again? It seems like it's hitting the loop even earlier. Okay, what is it saying here? Ah. Because it's, yeah, okay. So, trace show ID, so set.empty. And I don't want to start it off at non-block. Because it will become larger and equal to max block. So let's see here. Divs times loop size. So this is like 500. Okay, so let's see here. Max block minus. This is gonna be the mods. Mods equals a let's see, until loop, and then okay, so we know how long the loop is, and the loop offset incur. Blink, 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 da-dum. Dun, 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 dun. Okay, so it's gonna, so what is the current block? So until block, okay, until loop, and then non-block. Okay, so we're at loop number 2281. Ding, ding, ding. So I think it's actually a max block loop size. This is actually divs. We're gonna do max block minus until loop. Okay, so this is how many times a loop will run. Now mods will be the same. Max block minus until loop. This will be like the how many times it will run in the last one. It will run for 1400 in the last one. Ding, 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 ding. Okay, so let me put this on a right trace shift.empty and let's put this on max block minus mods. Okay, and then it has a... So then we'll see the final res. Oh, I don't want to show the threshold ID there. Okay, so then let me print out even more stuff. Okay, so offset and a loop offset incur. So before offs before equals offset minus off loop offset incur. Now let me see. Loop offset incur. Loop offset incur. Okay. The final offset and okay, let's do here final floor y max equals first of im.find max final floor. Now okay, so let's see, so it's offs before plus divs times loop offset incur plus final res plus final floor y max. Okay, from integral divs doesn't like it because from integral sorry times from integral divs ding, 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 ding. Okay, no, yes, so this is 10856.594. This is a lot. This is too much. So offs before, wait, so offset loop offset integral. Then we run divs loops. Okay, then final res is this This is not at all enough. Okay, let me see. So offset before. Okay, then a loop offset increment, and then final res, and then a final plus final for ymax. From integral. Okay, so the offset before. So every time you run the loop, it increases the offset by 1901. Now divs. So this is how many times we run the loop. Okay, and so let's print out a divs times loop offset increment. From integral Okay, let me check again one thing. Okay. Okay, so the offset before. Okay, so you have the. What is the offset here? Okay, so per loop it runs in maybe this should not be set at NP. Well, maybe. Offset before is a let's see, what is the loop size? Loop size. So 2389, and then you get a loop, and then until loop. Until loop is minus 108. That's not okay. No, this has to be ISC. Bing, 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 bing. Okay, so I take it and then run the whole thing. And when I see the beginning of the loop again, I know how many blocks it took, and I know the offset from 0 that each loop increments. Plus from integral dollar find im.find max for prime wait, and then this is a loop offset increment. Okay, no, this is just be offset prime. Yes, okay. Okay, so until loop is 539. Loop offset increment. Okay, and what is a offset prime? So yeah, okay, so that's the thing that I'm screwing up here. A offset, this is offs before, is offset prime. Offs before. Okay, so it's 813 and then 2759 per loop. And then okay, now we're getting pretty close to that number. What was it? 157186. 157186. Okay, so I want to say here, okay, so we do offs before plus a loop contrib equal divs times loop offset increment from integral offs before plus loop contrib plus offs before 1575654. Okay, that's too much. What about offset prime here? Plus loop contrib, and then we don't find the y max. Ding 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 ding. Ring. Let me see if anything going on. Ah. Still going. Okay. Okay, offset and ring. Ding. I want to do so. The ops before is 830, and all loops, and then okay. So then we run all those loops, and then we add the final res. F A A A E. Final after loop equals a final res plus from integral a final floor y max. Okay, let's see. Okay, so offset before, okay, and then this is the per loops, and then this is the final res, final after loop, Okay, so from loops equals this, right? As before, from loops, I would like to say that it's offset before plus from loops plus final after loop. So that's missing. It's missing. What if I do plus loop? Is there one loop missing? Plus loop offset anchor minus. There's not. What if I just short circuit here? Ding 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 ding. Okay, let's see what's here. And so let's see until loop plus divs times loop size. Okay, and then let it run it. Yeah, okay, this is the one. Okay, and then 103. What if I just do simulate prime? So I don't do it like this. I do set.empty, and I have this as the offset here is maybe it's not offset before. Maybe it's offset. No. 1577600. Seven 555. This definitely supposed to be offset prime. Loop offset increment. So I want to see what this is. I am $FST I am dot find max. FLM. FLM. Minus how many loops? Divs times FLM. FLM. I mean, we're very close. Okay, so one loop. This is the loop size. Maybe this is actually non-block plus 1. Let's see how that changes things. Okay, plus of seven 5 2 5 1 5 7 7 8 1 1 8 6 minus loop size minus from integral divs. There's a lot of guesswork involved today. We're very close. Like I said, the new block is in there. There was a collision. Lower down one. Okay, then the next. Yeah. Okay. So the loop size is this offset. Let's see. This offset prime is there. Okay, now that was definitely off. Yeah, this is definitely offset prime. Okay, now the loop size is this, right? Loop offset increment FLM. And the idea there is, yeah, if I start at these conditions with 0 and 0, I'll go for non-block plus 1, and it increases my offset, loop offset incur, and this is an integer and this is an int. So every time I run the loop, it increases by this number. So I detected a loop. Okay, so I do offset prime. Okay, so I do offset prime. Okay, which is like the current value, right? Offset prime, and then offset prime times my plus. I do loop offset incur times divs minus 1, right? From integral, and it doesn't like this. Okay, so this is so this is after I run the loops again, and then I have the final after loop. Plus a final after loop. And then, okay, and I seem to be missing something. One 577 525. Okay, so there's something wrong. Let me see. Ops before. Let's just see div. Let's just see. This is v equals this is 15. So this is v minus 1577186. The difference there is offset prime now offs before the loop. And then final res. Okay, maybe. Let me see. This is your block, symbol block. Okay, offset. Lower. Let's just turn this off and see what is it supposed to say again. But let's do it like for a different number. False. Let's simulate it not for 1,000,000, but for something like 100,000. Uh, 157586. One 576 922. Okay, I feel like I've seen this number somewhere. Let me see. Okay. V show V. Now let's not turn this off. Ding 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 ding. One's one. Okay, print Y and then print I am dot find max FL. Over the sheet. Print I am dot find max FL. Ding 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 ding. Okay, so this is also a trick, right? So what is the final res? Do 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 ding ding ding. Let's see here. Error show. I am not find the max final floor. Ah, okay, so the final floor is not correct. Interesting. Okay, that's important, right? So that's so this should be until loop plus a divs times loop size. Until loop plus divs times loop size. Scene unblock. Else the count here is Okay, I mean this should be the one that we want, right? But there's the Triceratops. Ding, 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 ding. Okay, so ding, 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 ding. I mean, this should for sure give the same as that, right? Let's do this for a smaller number. Ding, ding, ding. And this is going to be a bool. Short. If short and compressed. Let's see here. True. Ding. Ding, 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 ding. Okay, so the final floor there seems to be 94 from 4, 5, 6. So this is simply prime true break on loop. Okay, it doesn't break on the loop because it doesn't hit the loop. Okay, let's just have this be. It doesn't actually use that, right? Yeah, okay. That can just be true. Maybe I have to start on the floor. What if I do BL int int. Okay, I seem to be not even getting the final floor down. Okay, so what I want to do is it's not even close, right? Number outside floor down. Okay, this is not block, so this is the loop. Okay, this should be new block plus 1, right? No, this is a new block. And then this is the... max, okay, what is the FLM here? Okay, so the claim is that the loop size is 1752. Okay, so if I do here, let's see, floor prime new block imps prime. $94, okay, and we get the half a lamb out of that, and it's 71,752. Then if I do max block minus loop size, I should get the same black, right? I am dot find max final floor, okay, and then let me see, this should be I am dot find max, I am dot find max loop floor. It's not even it doesn't seem to be looping like that. Wait. Okay, so max block minus loop size minus 1. If the loop is this, it should be okay. What? Let me see. Fillet row, okay, and then it does run for loop size blocks, right? And with this floor prime, a new block and imps. Okay, and I'm claiming that I've seen this before, but it's not giving me the same. So this loop detection is off somehow. Let me see. Scene. Let's change the scene to be a map to int. Import data.map import qualified data.map as map. Okay, so ding 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 ding. Map.member scene, and then when we insert into it, map.insert a then this, and then scene, or is it key? Scene and then key, and then a new block +1. Num block +1. Okay, and then just a app.singleton 0, and here we're gonna go app.empty and simulate parent set.empty map.empty. Okay, let me see. And we don't need to run and get this loop size. We just need to look up what it was. What was the block number last time we saw this? Let's put this. Yeah, okay, this is the call, so num block +1 base scene. Okay, now let's do a let lk up equals in, and now let's print the lookup here. Let's print, no, not the lookup, let's print map. Okay, scene map.bang. Okay, up. Just 5 to 7, and now let's see until loop. Now let's see what the current block number is. Num block +1. Okay, so the loop size. I'm not gonna do this again. Okay. I don't need to run it again. I just need to check. So just prev scene equals map dot bang. Okay, up. scene. So loop size is equal to num block, also current block plus 1 minus prev scene. Maybe I should add the current map ding 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 ding. Offset prime okay, take away this because actually just int comma integer comma floor. Okay, and then this one is we take away this break on loop, and remove this break on loop crap. This is prev scene, and a PSF and a PSO. Okay, so loop size non-block plus 1 minus now divs non-block plus 1 minus a prev scene, right? In error $show prev scene num block simulate ns simulate Okay, let me check. So I want to see Let FOS F final floor is equal to simulate prime and map.empty. Now I want to see that if we go for 0, the offset, so final 0 here, and a floor prime, imps prime, simulate prime 0, non-block is also 0, floor prime, a new block, imps prime. Okay. Ding, 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 ding. Oh no, right? So I want to see here max block minus loop size. Final offset max FF. Okay, I seem to have says I'm off by 1 somewhere. Okay, so this block was previously seen at block 527. Then I am find max FF and I am dot find max floor. So these should be the same, right? But they are not. There is something very weird going on here. It's like it loops. So I was at block, so 27, and then I ran it. Maybe we should insert a new block. This is a okay up. We'll insert the lookup and then let's just have this no block plus 1. What if I run it 2 times? Do I get the same 5,56? Should be like that, right? No, then it's maybe it is off by 1, something like that. Org. Still yeah, okay, let's simplify this all. And let's just say here case lk up equals bl floor org. Let's just check out that. BL, so LK up equals BL floor org. Okay, so if we've seen this exact thing before, case LK up map.member scene equals error just r r comma whatever is going to be error dollar show r. Scene okay. Okay. That ns equals if compressed I only insert when I compress, and then I'm gonna just print it. Okay, okay, I just compressed and ding 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 ding. And I'm gonna insert the not the offset prime, but the offset in the floor. Okay, now this says show R num block. Num block. This is when we've seen it before. Okay, now I'm gonna do let loop in, so loop size is equal to num block minus R. Okay, and then I'm gonna say OSFL is equal to simulate prime max block minus loop size, and now it's definitely gonna be so map.empty, so we don't want to be looking up again. Map.empty max block loop size 0 floor BL org. Find max FL. Okay, but then it does loop. org OS org FL. Let's find max of floor and am.find max org fl. They should be the same for sure. Yes. Okay. But the current, the R and the num block are different, right? So now I'm 1755 blocks later and I'm seeing the exact same thing. Okay, but what is the current offset, and org offset? Org OS. Okay, so OS per loop is equal to offset minus org offset. Let's see, this is no offset, right? No, none of that crap. OS per loop. Okay, and first scene. No, this is gonna be first scene. So how many loops are there left? Each loop is 1755. Okay, so max block minus first scene and divs equals max block minus first scene divs loop size. Divs. Well, how many loops are there? Oh no, show R. Okay, so this is the first scene and then OS per loop. So divs, so I want to say that what is a divs times loop size (98208). Okay, and then I want to say first scene Okay, so now I want to say left. Outstanding equals this, right? First max block minus first seam plus divs times loop size. Okay, so outstanding is outstanding and with the floor and the peel and the org. So OS outstanding FL final. Okay, and so we want to have short here also, so that it doesn't do it when we don't want it to. So okay, so outstanding. So I want to see now a org OS plus a divs times wow, finally. Okay, so I'll return this. Amazing. Two, three. 1, 2, 3. By like some, loop prime, blah 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 blah. Final. This one has to be an integer as well. I plus from integral dollar first dollar im dot find max new block and see if this is correct. Well, let's run on the example first, maybe. Maybe it took a lot longer for the example to loop, right? Let's check it out. Wow. Thank you for those who stuck around the whole night. Anyway, git status, git add day 17. Oh, git add date 17, git status, git commit am date 17. Git push. But we did do it in a very short time, right? 0.52 milliseconds, but yeah. Okay. That's it. Thank you for tuning in. I hope you had a fun time. And, well, tune in later if you like. Alright. Thanks a lot. And goodbye.